Hey everybody, thought it was time for another project, so I got my grubby little paws on a Commodore 128. And remarkably good condition except for the stripe of, where is it? Yeah, it's on that side, the yellow stripe down the side. It's kind of weird, but I guess it was maybe right next to a window or something, just on that little edge. Other than that, this thing is in remarkably clean condition. It was a little fuzzy, a little dusty, but it cleaned up quite well. And it was sold as one of those tested, got a power light or it turned on or whatever. And it obviously didn't. The power switch was froze solid on this thing. There was I don't know if something got in there. There was a little bit of water-ish looking damage on the shield underneath, but no rot, nothing corroded. So we did good there. So I did video of changing the power switch, but it was extremely boring. So we'll skip that and get right into repairs and mods on this thing. And the moment of truth. We have our S-Video input selected, and we'll throw it some power. Well, it turns on, and holy jail bars, Batman. I heard they were worse on the 128, but that is absolutely ridiculous. We're going to have to dig into that a little bit. But I did check the output of the power supply before I plugged it in. The 5-volt line was right on at like 5.05 or something like that. So I don't have any fear that we're going to blow anything up, but it's probably not a bad idea to check voltages and all that other good stuff. So let's see. Go 64. Sure. Ha! Alright, well, this thing has some kind of memory error. I was anticipating some kind of problem. So, yeah, where's the other one? Yeah, there we go. Now you can see what I'm doing here a little bit. So, I burnt a 27C512 chip. This is nothing more than the C128 diagnostics, you know, the 8K file written 8 times, you know, to fill up the whole chip. I didn't feel like messing with switches or whatever to choose which memory bank. So in the 64 world, you have to put it in a cart, and I thought about parting out one of the diagnostic carts, but a little bit of reading, I learned that the 128 has an option ROM socket, this U36 socket, so we can just pop our little chip right in there and see if we can do this without bending pins anyway, and we should boot right into the 128 diagnostics. Socket's a little grungy. This thing will need a whole bath by the time all's said and done, but let's see what we get. Yeah, stack page bad, so that makes me think the first DRAM chip, and looks like 45, 40, and 38 have all tested bad. Some artifacts in the screen. Thinks everything is bad. I'm amazed it booted at all. At least the SID sounds good. Now, I highly, highly doubt every single RAM chip is bad. If it was, this board would not be working this well. Obviously, there's no harness hooked up, so the 6526s and whatever showing bad, I'm not super concerned about. Color RAM's okay. Yeah, and there is no way every single RAM chip is bad in this thing. Let's boot him again, see what he does. Alright, so 38, 40, and 45. And you know, I wonder, I want to say 45 is the 0 page, the stack page in this machine. You know, if that's bad, I bet it's going to do all kinds of terrible things. Let's try a C64 dead test cart. See which flashes we get. Alright, one flash. One flash, according to the manual, is supposed to be U45 and or 53, but being in 64 mode, it's not using bank 1 at all. So we're not even going to go there yet. Let's see if we can get a working 64 out of this thing first. Let's boot it one more time in a 64 mode. Yeah, add a memory in 0. That tells me that first chip, between that and the one flash, that U45 is almost certainly bad, and there's probably others, but let's change him out first and see how far we get. Got ourselves a new memory chip installed. It is facing the right direction. All our notches are in line. Plug in the DIN connector. Kick him back to S-video input. And the survey says stack page passed. That's a good thing. Color RAM looks good. Guess this is an extended memory test. It's taken a lot longer this time. I guess with that first chip being bad, it just dumped the rest of the test. Didn't even want to run it last time, just reported everybody is broken. Or did we crash? Oh, there we go. It's telling me 46 is bad. Oh, that other stuff showed bad because there's no harness. Don't care. Ah, but the SID works. Man, it's worth it just to hear a working SID. Alright, let's change out 46 and see how we do. Alright, RAM chip number 1 replaced, RAM chip number 2 replaced. And diagnostic ROM is still in the board. Nothing in the cartridge slot. Let's see how we do. Oh, now U50's bad. This MT RAM, I tell ya. I think when all's said and done, this board's gonna have 16 RAM sockets on it. But, alright, well. Gotta listen to the SID. So, alright, let's swap out U50 next, see how we do. Ooh, we're looking good. No whammies. Come on, little guy. There we go. A successful memory test. Alright, we're going to let diagnostics run on this machine for a little while, just to make sure we're out of the woods. Alright, after a dinner break and letting the board run for a while, we've got a stable machine. So, well, I got this board out and soldering irons warmed up and all that other stuff. Let's do the VDC upgrade. These two chips here, they're 16K RAM for the 80 column controller, goes out that RGB port. Let's yank these chips, put in a couple of sockets, and throw in some 4464s. Yeah, 44. Yeah, 4464s. I think that's the chip number. We'll make sure we find the right chip when we go to do it. But yeah, let's pull those two bad boys out and see what we can do. And behold, through the magic of editing, we have removed these little 16K chips. We need some 64K chips for it. However, looking through my stash, I realized I was out of them. But all is not lost. This is a 64 I recently repaired and added a Lumafix to it and stuff, but it needed new RAM, so these chips have run for just a few minutes in this machine. So we are going to borrow them. Well, I have some new ones on order because I got enough 64s coming out my you-know-what. So we will borrow these guys out of here for now. We've got some more in the mail already. I went online and ordered them real quick. And just so happens that the 466 boards, probably the 469s too, I think they use the same chips. I've never had one of those, but the C64 466 board, 250-466, uses the exact same memory chips for its system RAM. So let's do a little begging, borrowing, and stealing. Pop them right out of the 64 and into the 128. Maybe. Come on, little buddy. There's one. And two. Alright, we'll get this bad boy thrown back in a case and see if we can talk to that memory. Alright, so I found this little program. It's supposed to tell us how much memory's in the thing. I am not able to hook up to an 80-column monitor right now. I'm waiting for a plug or two to come in. So supposedly this program will print either a 16 or a 64 to tell us how much memory there is. Hopefully you do not have to be in 64, or I'm sorry, 80 column mode to do this. Here we go, 64. It sees all the RAM. So as usual, I have no plans on putting that RF shield back on, but got to make sure things get cooled. So a couple little stick-on heat sinks on the SID, and I went through, cleaned all the old white dried out paste off the board, and I'm gonna try something a little new today. Should work good. This is the Arctic MX5 thermal compound. And if it works good on a Threadripper, it ought to work good on this machine too. So this is newer stuff, not like the old stuff that had actual silver in it and was conductive. This is completely non-conductive, and as you put it on, it almost gets a little tacky fairly quickly. So it's kind of like the thermal paste from way back when, more so than it's a paste than liquidy. So we'll take our little cover here. He's gonna go on like so. So here we'll give these a little bend just to make sure they're gonna make good contact. Spread some of this paste on there. Or compound, I guess it is, not necessarily paste. Just like so. That's probably a bit much, but nah, nobody's gonna see it. And there we go. That should take care of the three hottest chips on the board. I'll have to go dig out some heat sinks, put them on the processors, and memory manager and stuff, because they get a little bit warm too. And then we'll run this thing for a couple hours and see how the temps do. Alright, we ran this machine for a while with the diagnostics ROM in there. Ran really well. The can got warm, but not ridiculously hot. I think the paste is doing a good job in there. That, whatever flavor it was, the non-conductive paste. The SID got a little warm, but honestly, I think the SID runs cooler than the SIDs on my C64. I don't know if that's a design of the board, or maybe this just, you know, this particular model of chip. The processors, they got a little bit warm, so we're going to heat sink those. These other two chips, one's the MMU, and I forget what the other one does. I don't really know the 128 that well yet. But they got a little bit warm, so we'll heat sink those guys also. And the 4 original ROMs here, they're not as bad as the mask ROMs in the 64, but they did get significantly warm. I don't want to say hot, but they were getting there. That being said, in order to reduce heat and drop some voltage load, I did a little Googling on the internet. Turns out you can swap out these 4 ROMs for 2 larger ROMs, and that'll be more in line with how the later 128 DCR was. They were larger ROMs, so you only have to populate half of them, because right now they're a low and a high, kind of like a BIOS in a you know, a 286, 386, you know, when they had the low and high chips. So I think we're gonna pop all these chips out and replace them with modern programmables that draw a little less power, make a little less heat. Ought to make the system just that much happier in the long run. So I made myself a cheat sheet of things we need to do, because there are some board mods that need to be done, and this is probably common knowledge to anybody who's worked on a 128 before. Like I said, this is my first one. I don't know what I'm doing with this thing, so we'll take some of what we learned off the internet, try to put it into practice, see if it works. So first and foremost, we'll have to do some mods to the main board. So we're not going to need these chips anymore. These, I want to say these are actual programmable ROMs, you know, one-time programmables that Commodore put in this machine. Not like the mask ROMs they used on the 64. So we'll get a little bit of anti-static foam, because these are good chips. We just want to try to make the machine a little better. And we're going to reuse our diagnostic ROM, because for the replacements, we are going to need a 64K chip and a 32K chip. So we're going to do some kernel switching as well. So he will get erased and reused. Now, as far as the board itself, there's a couple things we got to do on both sides. So we'll get him out of here. And from what I understand, the later DCRs, maybe even the Ds over in Europe or whatever, had this stuff done to it already. There's a couple of jumpers that have to be closed that effectively route both address lines to one socket instead of splitting it between the 2 sockets. That way we can address all the storage in the bigger chips. So first and foremost, we have to close J3 and J6. So J3 is right down here. Let's zoom it in a little bit. Alright, so J3 is right here under that little transistor, and we just need to close him shut. And they are through holes. We could put pins and jumpers and whatever, but I think a blob of solder will do the job. There's some spare wire laying around. Just put a little bit of filler in there so it doesn't all just run right through the board. This wire already has a little bit of tin on them, so ought to stick down real good and easy. Alright, so there's J3. I guess there's not very much solder on these pads. I'll load them up. And now that's jumped. We'll go find the snippies and cut off the extra. Alright, we got those two jumpers closed, and there's one more jumper that you would think just needs to be closed, but due to a, call it a hardware bug, it's not quite that easy. We have to do a little bodge wire. So the J4 pad right here has to be hooked up to, the one closest to the outside of the board here, needs to be hooked up to address line 15 to get the data routing where we need it to between the sockets and the CPU and all that. So if looking at this picture online, there is a chip right below it. There's another row of pins here. This line right here, if you tone it out, will go back to A15. Just make sure I'm looking at the right one. Yep, that is him. Double and triple checking. Yep, that is absolutely him. He's going to be A15 there. So I'm going to make a little mark on the board so I don't lose my place. That right there needs to go to right there. And I found this off a blog, I want to say a German blog, but it was written in English at least. And I will link that below. None of this is my smart work. I'm just the guy with a soldering iron. Here, we'll take this itty-bitty little bit of wire and come off this pad like so. I'll zoom it in a little bit so you guys can see. Arrange the camera as such. So, yep, there is our mark. And there is our pad. He's just going to go on like so. He's on there good, and let's route him nowhere near other pins that will poke him. We'll put a little glue on there and stick him down so he doesn't move. That pad there is where we want to go. We'll cut this a bit long. Get our itty bitty strippers. We need a little more than that. There we go. He's going to lay down just like that. Around and between all those little sharp pins coming through, because we don't want to poke this and short it out. A bit of tin there, a little bit of tin there. We'll put him on just like so. There we go. Now A15 is hooked up, so we can just run a pair of ROMs instead of 4 ROMs. Alright, time to cook up some ROM. So we have all the ROM images we needed in one directory on my iDrive here, and basically we're going to take BASIC and kernel, BASIC and kernels, and cook them all on one chip. Alright, so BASIC's got to go first, then the C64 kernel and the 128 kernel, and then we're going to do the same thing for Jiffy DOS on the other one. So go out, buy a copy of Jiffy DOS if you're going to do this. There are copies floating around the internet, but be cool, support them. I did that this morning, bought a license, I think it was $13 for the C128, comes with both of these, right? So we just copy them all into one big file, file plus file plus file, so on and so on, and we're calling this U32 64K.bin. So we'll come into our handy dandy little burner, and this is the file we just created. Hit OK, and program. Now, the other ROM we're going to need will fit on a 27C256 as opposed to a 512. That's 256 bits, so that's 32 kilobytes. And got one of those chips here that we will pop in the burner next. And for that one, here we'll go ahead and change this. And this is a 27C256 from ST. And it's a DIP 28. And is this a B? Yes, it is. It's 27C256B. Just have to make sure you check to make sure your chip matches the chip you pick over here. And what's that other file name? I forget. That's right, I named it U34. I was thinking ahead. So here we'll load file, U34. This is the 128 BASIC, as opposed to the 64 BASIC that goes on that Commodore ROM there. And we will put a little chip in a little programmer and hit program. When this is done, we'll have a pair of ROMs, and we'll have to do a little bit of trickery and wiring with a resistor and a wire to make sure we can switch between the two banks on the kernel ROM, so we can go back and forth between Jiffy DOS and the regular Commodore kernel. Alright, we've got our two ROMs burnt. This is the easy one, the 27C256, the 32K BASIC ROM. You just plug right into U34 and you're done. I'll print up little stickers to put over it to remind me what exactly is on the ROM and cover a little glass window. I don't think it's absolutely necessary inside a box. Might as well put it on there. So the 64K ROM. Now these sockets now instead of being split up for a couple of 8 or 16K chips are set up for 32K chips. This is a 64K chip because we have two different kernels. We're going to want to use it two different times. So that being said, pin number 1 over here is address line 15 for the chip, and we're going to want to toggle that low or high depending on which kernel we want to boot from. Now the board, and where does he go? He goes in U32, maybe? I gotta go back and look at my notes before I plug this in the wrong hole. Yeah, U32. So before we go and put this into the U32 socket, we want to bend this pin out because this pin coming out of the board is going to supply 5 volts to it. We don't want to supply 5 volts to it. We want to have it basically tied to ground. When how does this work? They're active low. So when you tie it to ground, it will enable the second half of the chip, which is Jiffy DOS. Or if it's up at 5 volts, and we're going to get that from VCC on the other side by way of a pull-up resistor, So we're gonna bend this pin out ever so slightly, because one day I might want to use this chip for something else. But we'll bend that little pin out, maybe just a little more, so he does not make any contact with pin 1 in the socket. And we'll go ahead and drop him in the board. Come on, little guy. There you go. Alright. So we got pin 1 out in left field here. And what we're going to do is attach a 4.7K resistor over to VCC, which is on the other side of the chip, right? So we can just strap him right on top like this, tie him in there, and tie him in there. And this will allow us to make sure the chip is active when it's not being pulled down to ground. So it's just a little fiddly to get this exactly where we want them. That ought to work right there. If I was smart, I would tape this guy down. But instead, we're going to fight with it. So then on the other side, we also have to put a wire that goes to the toggle switch. So I want to get this side tacked down first, because he is less fiddly, because it's only one connection instead of two. Let's see if we can get this first shot without knocking the resistor over. You know what? We should tin the pin. Just the tiniest little bit of solder on there. We got some tin on the resistor now. You know, maybe we just put something heavy on top of it. There we go. That ought to hold them enough. A little bit of heat and a little bit of solder. And he is tacked down to the chip now. And on this side, I have a toggle switch here with some wire attached to him already. And granted, you can just do this with a single pull, single throw, but this is what I happen to have laying around. So we're going to take the red wire and go to pin 1 on the resistor, and the black wire, we're going to go all the way down to ground on pin 14, and I believe these are 28s, 28 pin chips, so 14 should be there, and that would be 15. All right, 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14. Just like the sanity check. Let's see, that should be just about the right amount of wire. Get a little strippy with it. And we'll throw a little tin on this red wire. Blob of solder on the chip and the resistor. Alright, he looks good. And we'll tack our wire on this away. He is on, and then the black has to go to pin 14. Guess you could ground it anywhere, but to keep noise off the bus, ground it right to the chip. And And I'm doing this right in the socket, so if you're doing it this way, be very careful not to use too much solder, because you'll wind up soldering the chip to the socket. And that'll just be a big mess to clean up. There we go. Alright, now we should have a switchable kernel and BASIC installed. So let me cut these legs off of here, and we'll get them plugged back in and boot him on up, see what he does. Alright, for the moment of truth, for the time being, I just have the wire hanging out of the back of the computer. I don't know if I'm going to drill holes in the case, do something with an Arduino maybe, I don't know. But at any rate, we have our toggle switch, we're wired into a chip, chips are flashed, we're running 2 ROMs instead of 4 now, and fire in the hole. Not bad. Not bad. So you see now we have copyright 1986 for the BASIC. That's the updated BASIC. Doesn't have the Q bug and a couple other little fixes I guess they had in there. So that is all good. And we obviously booted to a kernel. So let's shut off the computer, flip the switch, turn them back on, and we got Jiffy DOS. Not too shabby. Alright, so now that we know that worked, I think we're going to go for extra credit. Because we have an option ROM socket, and I have an abundance of ROMs. Let's, I think I'm going to burn up a ROM to go in here, much the same way. There's a bunch of options out there. Basic 8, I'm probably not going to use. I'm no programmer, I just want to use this thing. So there's a thing called the Servant I heard about. It's supposed to be some cool thing for the 128. And I thought it'd be neat to have a GEOS ROM in there. So we'll do the same thing. Install the chip, resistor across the top, toggle switch, and we ought to be able to switch back and forth between 2 different option ROMs. And I do believe you can bail out. I think you hit stop as you're booting, and you will bail out to the machine language monitor. You can exit out of there, and you can get into BASIC. So it's kind of like a 3-in-1 almost. So I'm gonna cook up a chip, install it the same way, and we'll see how we do. Alright, just like we did the other ROM, we're just going to bash these 2 files together here. We have the Servant ROM and GEOS 128 for the 1581, because I'll be using a, what is it, the little Pi 1541 emulator, right, in 1581 mode for this machine. So we will paste those together like so. And where's our happy little EEPROM burner? We're going to change this back to kind of chips were these anyway, WinBond 27C512s. So there's the WinBond 27C512 DIP28. Select, load file, and here is the Servant ROM. Servant and GEOS ROM. That will burn him up and install him. Alright, now for the next moment of truth. We've got both our ROMs wired in. We got toggle switches for both of them. And a keyboard. So fire in the hole. Alright, we had Jiffy DOS. It booted to the Servant. And you know, we never tested Jiffy DOS in 64 mode before. Alright, that works. So we'll boot up without it. Okay, so we've got kernels and BASIC working on both sides of the house, so we are golden there. I have the GEOS 128 disk image to auto mount. This ROM, think of it almost like a Kickstart ROM in an Amiga. It helps you get going, but you still need a disk to load software. So we will shut it off, flip over, drive reset, and we are seeking. Awesome. So I'm absolutely sure that it is loading, because I see the little Pi doing his deal. But we're not going to see anything on the 40-column output. The GEOS ROM is 80-column only when you boot that way. So I'm confident when I finally get this thing rigged up to an 80 column monitor, we'll actually see what's going on. So I would say our ROM switching is a success, and that's pretty slick. I wonder what other option ROMs are out there. Maybe I can build a couple of different ones. All right, well, I think we've gotten to a point we can call it quits for a little while. We have the Servant and GEOS 128 ROM and the option socket on the switch. C128 kernel and Jiffy DOS, and the later BASIC from 1986, BASIC 7 from the later 128 DCR model. So those are in there and labeled. 3 new RAM chips. I ordered sockets for all this. This is all empty RAM. It's gonna die. Everybody knows that. So I have RAM and sockets on order. We're going to go through and socket all the RAM and get all the empty chips off the board. If for nothing else, for the sake of principle. We're just going to throw those things in the trash. What's that? Character ROM and color RAM. Yeah, it's the SRAM for the color RAM. Put little heat sinks on those. They don't get terribly hot, but I figured I'd do it anyway. Same goes for the 6526s. They don't get super hot either, but I was going crazy with heat sinks, and they just look cool. So, heat sinks for everyone. And then the 8500 or 8502 and the Z80. Those guys actually do get kind of warm. As do the I forget, one of these is a memory manager. The other one is probably a PLA or something. I guess would make sense. But they got a little warm. The processors definitely got warm. We got these other heat sinks with more fins, more surface area on the SID. I think they do a better job. And the what, M8, X8, whatever the hell that stuff was, that high-end heatsink compound we put in there. All the chips have been cleaned to the old nasty stuff. That heat shield ain't going back in here. You know, the so-called RF shield. It's really just a heat shield that keeps all the heat inside this poor little guy. A couple of switches dangling out the back for now. We got to come up with a solution for that. So in the future, might wind up doing an Arduino and some kind of keyboard combination to drive it to switch the ROMs around, kind of like I did on the 64. And yeah, I think that's it. We got ourselves a working machine. I have an RGB adapter coming in, and we're going to be able to drive that to one of those GBS 8200 boxes that I had already. I was really looking for the RGB to HDMI, but they're in short supply right now. I don't know if it's a chip shortage thing with the CPLDs that were on there. I could definitely see that being an issue. I know a lot of that stuff's in high demand. So we'll make do with the GBS for now. I hear they're not great. Like, the colors are a little bit off, but hey, it's close enough. I just want to see if 80 column mode on this thing works. And we have a something coming to replace this guy. Get him out of there and do something about the jail bars. I know it'll never be perfect, but we got to do something because the video coming out of this machine is absolutely horrendous. So yeah, with that, I think I'm gonna button her up for now, and probably do another video later with the video upgrades. So take care, everybody. Thanks for watching.